Hello everyone, this is another student's quest. This question I received today morning from Amey from Pune. So early morning I tried to do this question within 10 minutes, but it was messed up. Then I confirmed the correct answer from Amey himself, and the correct answer is 768. So before you see the solution, I request you to attempt this question by your own. Then only you can understand the value of the solution I'm going to provide. So the question says that y is equal to fx be a function satisfying this cubic equation, and the x is lying between 0 and 3, and the number of functions that are possible such that fx is discontinuous from at the point 0, 1, 2 and 3 is k. Then the maximum digit of the value k is what? So basically we have to find out the value k. Our prime goal is to find out the value k. So for that, it's not so difficult to understand that we have to break this cubic equation down so that I can identify what the function value equal. So let's say y is equal to fx, and I call it y cubed minus 3y squared plus y plus 1 is equal to 0. So it's natural that we can give trial and error. So y is equal to 1 is satisfying. So that is going to be y minus 1 into, and there's another quadratic equation, y squared minus 2y minus 1 is equal to 0. So we get three values of the y, that is 1, and from here I get y is equal to minus 1 plus or minus root 2. Sorry, I think 1 plus root 2, 1 minus root 2, yes. So 1 plus root 2, and again y is equal to 1 minus root 2. What does it mean? That the function can assume these three values, and these three values, let us call it like a is equal to 1, b is equal to 1 plus root 2, and c is equal to 1 minus root 2. Now I have to find out such functions. These are all constant function to b, because fx can assume only these constant values, and those functions should be discontinuous simultaneously at 0, 1, 2 and 3 in the interval 0 to 3. So let's see how we can think after this. So the idea is very simple, but to crack this simple thing we have to work a little bit complicated. So what is this idea? What I'm thinking, that let's say I have these intervals 1 to 2, 2 to 3 and one interval 0 to 1. So I'm calling these intervals, let's say I1 as the interval 0 to 1 excluding 0 and 1. The interval I2 I'm calling 1 to 2 excluding 1 and 2, and similarly I3, that is 2 to 3. All right, and I'm focusing on the interval which is in the middle first. Means I'm just calling, let's say, this interval I2 1 to 2, and I'm giving this a value. Let's say this value is assumed a is equal to 1. Now in this situation, what are the possible cases in which the function is not going to continuous at all the mentioned point? We will count, and if we count for a is equal to 1, again I will give the value a is equal to like the value b and the value c, and then the answer will come. So let's see what we can do here. So I'm fixing that f of I2 is equal to a, and a can be any number, but let's call it is 1. Now in this situation, let's focus on the point at x equals to 1 first. At x equals to 1, when the function can be continuous, let's first decide. So it is continuous when I have the f I2 value is equal to f1 value is equal to f I1 value. Let's focus, let me repeat it. F I2 means this interval value, that is 1. F1, this is this particular value at 1, and then this interval value. Because I have taken this 0 to 1. I am not considering the 0 here. We will see the end point what will happen. So let's say this is the first thing we are taking at 1. Now, since fi2 is fixed, f1 and fi2 should be again that same fixed value so that the function become continuous. Let's first decide what are the number of choices for f1. So for f1 I have how many choices? It can be A, it can be B, or it can be C. Similarly, f of I1 here, this particular interval I'm talking about, this has also 3 choices. What are the choices? Again, A, B, C. It means in total the function is continuous or not continuous at 1. I have 9 different choices to make it. So the number of all such cases or maybe such choices, I can say this is 3 into 3. But the number of discontinuous choices is going to be 3 into 3 minus 1 only, because there is only one possible case in which the function can be made continuous when all these 3 values are equal to A. So any of the other 8 choices, if you take, that function will not be continuous at x equals to 1 provided f of I2 is equal to A. But this is the story for x equals to 1 only. We have to also tell the similar story at x equal to 2. Let's create the story. So what will happen at x equal to 2? So let me make this point clear. So at x equal to 2, what will happen? Again, we see that the continuity will happen if you notice that this interval I have already fixed. So I have to now fix the f2 and the I3. So I can say the fi2, then f2 and f of I3, the third interval. fi2 is already I have taken, please remember always. Again, this guy f2 has 3 choices, the A, B and C. And this guy has again 3 choices, A, B, C. It means the number of all such choices again will become 3 into 3, and we subtract one such choice in which the function cannot be cannot be discontinuous, means can be continuous at 2, that is 1. So this is going to be again, I'm writing number of discontinuous choice I have, that is 9 minus 1, that is again 8. So we will keep them aside because we are going to use it. But notice these all are happening together. Please remember, it's not like a either or case, because if I2 is equal to A is one such fixed interval in which fixed value of that interval I have taken. In that fixed value, everything at 1, at 2, at 0 and at 3 are happening together. So why we have to keep this in mind? Because this I have to multiply. Now what will happen at the end point at x equals to 0? What I'm writing. At x equals to 0, what will happen? If x equal to 0, the f of 0 plus, because the left hand must be equal to f of the value at any of the value what we take in that interval, means the closure value. But the problem is that in this interval, you notice the function is going to be continuous only, means continuous in the sense that the function is going to be constant only. So f of 0 plus must be equal to the value of this function in the interval only. It means I can directly tell without just circumlocution that f of 0 plus is going to be f of I1. Okay, So f of 0 plus f of y1. Now notice not 0 plus, basically it's a 0 by the way. I have to write in this way. Means I wanted to call that f of 0 plus is f of i1, and so it is equal to f of 0. But now you understood. So this is going to be, now this has already, you have taken 3 choices, and it has to be discontinuous at 0. So if f0 will also take any of the 3 choices that fi1 has taken, the function will become continuous at 0. That I don't need. It means I have to give actually this f of 0 2 choice. So in this case, the number of discontinuity as 0 is going to be in the 2 cases. Okay, provided f of i2 is fixed. Similarly, we go for the last n, x equal to 3. So x equal to 3 means 3 minus, what I'm writing, f of 3 minus must be equal to f of 3. F of 3 minus is nothing but our f of i3, and f of 3 is there. I3, since while deciding the discontinuity here at 2, we have already taken that value is going to be have 3 choices, and f of 3 now I have 2 choice only. So this 2 will come there in total counting. So what will happen if I assume that f of i2 is equal to a? These are the possible number of discontinuous functions they're asking. So what is the total number of discontinuous provided f of i2 is equal to a fixed quantity a is going to be 8 into 8 into 2 into 2. That is going to be 16 into 16, that is 256. But this was only the story when I have taken f of i2 is equal to a. F of i2 can be b also. F of i2 can be c also. So in this case, if I combine all those cases, therefore total number of discontinuous, because f of i2 I can fix any of them, a, b and c, is going to be 3 times 256, and that is going to be 768 as the final answer. So this is the value of k, 768, and the biggest number is going to be 8, and that's the answer. So I hope you understood this solution. That's all for today. See you in the next video with some other interesting question and the solution. Till then, stay math active.